Today's topic is Newton's ring. Outline, introduction, numerical problems based on Newton's ring applications. For Newton's ring are formed due to interference between the wave reflected from the top and bottom surface of air film between plano-convex lens and glass plate. This is a plano-convex lens and this is a glass plate. If AB is a beam, if AB is a beam of monochromatic light which falls on a plano-convex lens, a part of light is reflected at C, means bottom of the lens, of plano-convex lens, which comes out as ray 1, without any change in phase. The other part is refracted along CD. At the point D, it's again reflected and comes out at ray 2. With change in phase of pi, the ray 1 and ray 2, these two rays, will interfere and produce the pattern. That pattern in rings form, which is known as Newton's ring. The path difference is calculated between these two rays is delta is equal to 2 mu t cos r plus theta plus lambda by 2. So we can write it as delta is equal to 2 mu t cos r plus lambda by 2 if theta is very small. For normal incidence case, and if we are using the film with air, then we can write mu is equal to 1 and r is equal to 0. So that comes to delta is equal to 2 mu t plus lambda by 2. At the point of contact C, let thickness of the film is 0, then the path difference must be lambda by 2, which is the condition of the minimum intensity. Thus the center spot is dark. For nth maximum ring, we have 2 mu t plus lambda by 2 is equal to n lambda. For maxima, for minima, that comes to 2 mu t plus lambda by 2 is equal to 2n plus 1 lambda by 2, means path difference is equal to 2n plus lambda by 2 and path difference is equal to n lambda by 2 or tn lambda. Okay, by using this, we can calculate the diameter of the dark and bright fringe. So for this, here the curvature, the diameter of the bright and dark rings, consider a plano-convex lens. Suppose say this one is plano-convex lens AOB placed on a glass plate, that is PQ. Let R is the radius of the curvature curved surface of AOV of the lens, and T is the thickness of the film at the point F. Suppose say if we are considering a point F is here, so this is the thickness F, and the thickness of the film is T. So this is the center point. Radius of the curvature is R, and the ring which is produced from O to F is radius small r, and the capital R is the radius of the curvature. So by using, and T is the thickness, so this distance, this R is from ABO, R is from CO, CO is equal to capital R, and this one is suppose E, then CE is equal to R minus T, because G, FG is equal to, we are considering the thickness of the film is small t. So FG is T, means that is also equal to T. Suppose say L, so LO is equal to also T. So rest C, sorry, E, not O, it's E. LE is also T. So rest C is equal to R minus T. By using Pythagoras theorem, here we can use CF square is equal to CE square minus CEF square. EF is small r. Or suppose say we are considering the nth film, so we can write it as Rn. CE is R minus T is whole square is equal to CE. Sorry, this one is, yes, CE. CF, sorry, CF is CE, CF square is equal to CE square minus CE square plus CF square. So this CF we can calculate. CF is what? CF is R. CF is capital R, similar as CO. So R square is equal to R minus T ka whole square is equal to EF. EF is R plus R square. So R square is equal to R square plus T square minus 2RT plus R square. Sorry. Here R square is cancelled out. Here R square is cancelled out. Then terms is 2RT is equal to T square plus R square. The thickness of the film is very small. Here we are squaring these values. So T square is more small. So we can neglect the T square, that comes to 2RT is equal to R square, or we can write it as T is equal to R square by 2R, where R is the radius of the Newton ring, capital R is the radius of the curvature, and T is the thickness of the film. For bright ring, we can use condition 2 mu T is equal to 2n minus 1 lambda by 2, or we can write it as for T is equal to R square by 2n, to 2 mu is equal to R square by 2R is equal to 2n minus 1 lambda by 2. For R square equal to 2n minus 1 lambda ry to mu, or we can write it as diameter dn square is equal to 2 into 2n minus 1 lambda ry mu. Okay, or we can write it for air film mu is equal to 1, then the dn square is proportional to 2 into 2n minus 1 lambda r. For a given lens, radius of curvature is fixed. For a source, if we are using source, suppose a sodium lamp, the lambda is also fixed. So here dn is proportional to only for the dn square, or dn is proportional to under root of 2n minus 1, where if we put the n is equal to 1 2 3 4, then the diameter of the bright rings are proportional to square root of the odd natural numbers. Here we can say, because r is fixed for radius of curvature of a given lens, lambda for the source is also fixed. Here dn means diameter of the ring is directly proportional to the 2n minus 1. Here if we put n is equal to 1, so we can say d1 is proportional to root 1. If we put dn is equal to 2, n is equal to 2, that means dn is proportional to root 3. Similarly, we have Vn root 3, root 5, and so on. Here we can write it as the diameter of the bright ring are proportional to square roots of the odd natural numbers. Okay. For dark ring, we have the condition 2 mu t is equal to 2n lambda by 2 or n lambda by 2. Here we can write it as, we can write it as 2 mu r square by 2r is equal to n lambda. Here we can find out the r square is equal to n lambda r by mu, or we can write it as dn square is equal to 4n lambda r by mu. For a air film, that mu is equal to 1. In that case, n is proportional to n 4 lambda r. Here also 4 is a constant, lambda for a given source, that is also constant, r is the radius of curvature is also constant. If we put n is equal to 0 1 2 3 4, we have dn is proportional to, if suppose say if n is equal to 1, n is equal to 1, and d1 is equal to root 1. If n is equal to 2, d2 is equal to root 2, and so on. Here we have root 1, root 2, root 3, root 4, and so on. So the diameter of the dark ring are proportional to square root of natural numbers. Here we can write it as the diameter of the dark ring are proportional to square root of natural numbers. For bright ring, we can write it as the square root of odd natural numbers. The only difference is because we for bright ring we find the root 1, root 3, root 5, and so on, means odd natural numbers. Here we find the 1, 2, 3, root 1, root 2, root 3, and so on, all natural numbers. So here we can write it as proportion to the square root of natural numbers. For numerical, the numerical is Newton's ring are observed normally in reflected light of wavelength 6000 angstrom, the diameter of the 10th dark ring is 0.50 centimeter. Find the radius of curvature of lens, radius of curvature of lens, and the thickness of the film. We know dn square is equal to 4n lambda r. This is the condition for the diameter r. We can write it as dn square by 4n lambda. Here we have lambda is equal to 6000 angstrom, which we can write it as in centimeter. That comes to 6000 into 10 to the power minus 8. 6000 into 10 to the power minus 8, or we can write it as 6 into 10 to the power minus 5 centimeter. For 10th dark ring, means n is equal to 10, and the radius is 0. The diameter of the diameter of the ring means dn is equal to 0.50 centimeter. So put this value, r is equal to dn is 0.50 per square upon 4, n is 10, and 10 and lambda is 6 into 10 to the power minus 5. That comes to 106 centimeter. For thickness of the film, we have a relation T is equal to R square by 2R. Okay, this one. We have a diameter, so we can write it as 2T is equal to D square by 4R. Or we can write it as T is equal to D square by 8R. D is 0.5 per square. 8 into R is 106. That comes to 3 into 10 to the power minus 4 centimeter. So we can calculate the thickness of the film, and this one is radius of curvature of the lens. We can also calculate the wavelength if we have a diameter, number of rings, and radius of curvature. We can also calculate the length. If that question is based on that, suppose say this dark is replaced by the bright, so we have to use the relation of the bright phase. dn square is equal to 2 into 2n minus 1 lambda. Okay, these are the references.